Start-stop systems automatically shut off the engine when your vehicle is stationary to improve fuel efficiency. However, these systems can fail for several reasons that we need to understand. A start-stop system relies on multiple sensors and control units. The engine control unit monitors crankshaft position, camshaft position, and various speed sensors to determine when it's safe to shut down and restart the engine. Start-stop system failures fall into three main categories. Battery-related issues account for 60% of all failures, making them the most common problem. Environmental and operational factors cause 25% of failures, while mechanical and sensor issues represent the remaining 15%. Battery problems are the leading cause of start-stop failures. Degraded AGM or EFB batteries lose their cycling capability over time. Using the wrong battery type, such as a standard lead-acid battery instead of the required AGM battery, will cause system failures. Cold weather can reduce battery efficiency by 20 to 50%, and faulty battery management systems provide incorrect data to the engine control unit. Environmental and operational factors cause 25% of start-stop failures. The system typically disables itself in temperature extremes, below 5 degrees Celsius or above 35 degrees Celsius. Frequent short trips prevent the battery from fully recharging, and high electrical loads from air conditioning or heating can overwhelm the system. Mechanical and sensor problems account for 15% of failures. Start-stop systems put extra stress on starter motors, causing premature wear. Various sensors must work correctly: brake pedal position sensors, clutch sensors in manual transmissions, steering angle sensors, and even hood latch sensors. If any of these sensors malfunction, the system will disable itself for safety reasons. Modern start-stop systems have evolved significantly to address these failure modes. Advanced battery management systems now monitor individual cell health and temperature. Predictive analytics use artificial intelligence to learn driver behavior patterns and optimize system operation. Enhanced sensor networks provide better integration and improved reliability, reducing the likelihood of system failures. Understanding these three main categories of start-stop system failures, battery issues, environmental factors, and mechanical problems, is essential for proper maintenance and effective troubleshooting. Effective troubleshooting of start-stop system failures requires a systematic diagnostic approach using specialized tools and techniques. The first step in diagnosing start-stop system issues is using an OBD2 scanner to check for specific fault codes and monitor real-time battery parameters. Battery testing is crucial for start-stop system diagnosis. Two primary methods are used: conductance testing and load testing to assess battery health and capacity. When battery replacement is needed, using the correct AGM or EFB battery specification is critical. Standard lead-acid batteries cannot handle the frequent cycling demands of start-stop systems. Software solutions often involve ECU reprogramming and battery management system recalibration. These procedures ensure the system recognizes new components and operates with updated parameters. Regular maintenance is essential for long-term reliability. AGM and EFB batteries should be replaced every 4 to 6 years, and charging systems require periodic inspection. Future developments include mild hybrid integration and predictive maintenance systems. These technologies promise improved reliability and performance through advanced monitoring and 48-volt architectures. Successful start-stop system troubleshooting requires proper diagnostic tools, correct battery specifications, software updates, and regular maintenance. These practices ensure optimal system performance and longevity.